Another thing I'll try to explain or talk to you is the PID block diagram. As instrument guys, the PID is the way we can communicate to each other as technician. So no word needed here, just must be block diagram. Let's take the one we're doing in the lab for example level control. Because if you see, we had somewhere there storage tank, we had on top a control tank. So water was flowing from the control tank to the storage tank, and that side we had a hand valve. Okay, the whole scenario is that way. We have water flowing from the storage tank using a pump there. So the pump need to pump the water up to the control tank, the top tank. But for that to happen is continuously, but we need to control it. So to control, we need a control valve. This is the control valve. Okay, then what happens? We need to set up the level here. Where do you want the level to be every time? For this whole thing to happen, remember we call this a control tank. So to control, we need something called a controller. I can draw my controller there. In our case, we were using an Arduino, which is a controller. Then the controller needs to communicate with something which is a PC. So at the same time, the controller needs to communicate to the PC, and also the PC must communicate with the controller. How the whole thing happens? So how the controller knows that the level is at a given point in the tank. That way you saw that we had a level transmitter, okay, which also had another plate because the tank is plastic. There's a capacitance there. So as the level increases, the capacitance changes and gives you an output signal which is voltage. In that case, this signal is a small signal. I think it was 0 to 2 millivolts. It's very small. So we're using a AC bridge. Okay, there was an AC bridge to convert it to give us an output from 1 to 5 volts. This now becomes the input to the controller, to the Arduino. Then what happens? Your set point, where the set point is the point where you want the level to be in the tank. Let's say you want the level every time to be at 50%. How does the controller knows that the level is at 50%? You guys, what I want you to do is to plot this graph. Do something like this here. So you have this graph, it's linear. You call this your voltage, it's 1 to 5 volt. This is your level. Percentage, it's 0%. On the other side, put 100%. So the controller, if it receives 5 volts, in another way, it means that the level is at maximum. It's going to be 100%. If it receives somewhere there, maybe 2.5 volts, if you take it there, it means that will be at 50%. So the controller only will receive voltage. Using this graph, it can tell where the level is. So if you want the level to be, for example, at 50%, so the level transmitter will send a signal depending on where the level is to the controller. This can be Arduino. Then the controller will communicate to the PC. Is in the PC where you're going to put your set point of 50%, for example. Then what the PC does, the PC gonna now talk back to the controller, and the controller will give you an output. I'm putting this is 1 to 5 volt. But because the control valve need current, we have here what's called a signal converter, which will convert the signal into 4 to 20 milliamps. Remember, if the valve receives 4 milliamps, it will be open at the minimum state. if it receives 20 milliamps, the valve will be fully or open at the maximum. Looking at the whole scenario, if you want the level to be at 50, and at this point the level is somewhere here, the level transmitter will send a signal to the Arduino or to the controller telling it where the level is in the tank. So in that case, if the level is at 30%, the Arduino will communicate to the PC. The PC now will communicate back to the Arduino telling it to send more current. So it will send more current and the valve will open again. There will be more flow coming in. Remember in this instance, the water also is going out there. So there's water going out and water coming in. And when it reaches 50%, your set point, the level transmitter will communicate with the controller, and the controller will communicate with the PC. The PC now will talk to the controller, telling it to try to adjust the flow or close the valve so that the water coming in is the same as water going out. So at that point, it means you are able to maintain the level at the given point. That's it. You have to understand. Good luck again.